All right, let's go ahead and get started with this lesson, lesson 5-7, day 2. Pause the video and read the question and try to see if you can simplify this expression for on your own first. So the question is saying for us to write an expression that would represent how many more. Well, let's say one team scored 10 runs, another team scored 8 runs. It would be 2 more, wouldn't it? So this is a subtraction problem. So we take the one with more, the home team, and we subtract the one with less, the visiting team. So this is another subtraction of algebraic expressions problem. We're going to go ahead and rewrite this, hopefully nicer than I wrote it the first time. Add the opposite. We're going to distribute a -1, right? That's what that minus sign means. I'm going to switch my parentheses to brackets because I'm going to put parentheses within parentheses on this first step. When I do my rule for subtraction here, and I draw 2 sticks, add the opposite, and here. So since these parentheses are going to end up having parentheses inside, that's why I switched to brackets. We learned that last lesson, right? So we're going to go ahead and simplify both sides by distributing, and then what? And I hope you said combine like terms. So let's distribute first. I'm going to copy the information down that I'm not using yet. Okay. The information I'm not using is x plus 7 plus, remember, when we do that rule for subtraction, we can put a plus sign in the middle of everything. So I got -1 times 3x, which is -3x. And -1 times 7 is +7. And after we distribute, we combine like terms. Those guys are opposite teams, so I subtract. Negatives have more, and 7 plus 7 is 14. So this is the expression they told us to find. This represents the difference between those two. But this actually isn't the whole question today. There's a second part. It says evaluate the expression if the value of x is 6. So we're learning a new skill today. We're going to evaluate today. And to evaluate means to substitute the value for the variable, the number for the letter, and simplify. That's what it means to evaluate. So I already know the expression that represents the difference between these two scores. But if x is 6, then I can plug in 6 where x goes into my simplified expression right here. So I'll take this and I'll plug in a 6 where the x goes. Multiply before we add. And we will get a +2 there. I almost wrote negative. So x is 2. Now we can check this pretty easily, right? The difference in runs is 2. Home team scored 2 more than visiting team. So if x is 6, let's see if this worked. So if x was 6, then remember it's not 2. 2 was the difference between those guys, okay? So if x was 6, then the home team scored 6 plus 7, right? I'm getting that from here, which is 13 runs. The visiting team scored 3 times 6 minus 7, which is 18 minus 7, which is 11. So you see there's a difference of 2. So we're not finding the value of x this time. We're finding the answer to this question. We're going to evaluate for how many more. Whoops. All right. Let's go ahead and go on to the next problem. I want you guys to pause the video and see if you can answer this question on your own before I help you with it. So we're going to write an expression to find how many more customers visited the store on day 1. So day 1 has more. Day 1's the big one. We'll put the big one first when we subtract. So it says the number of customers on the first day. So first day is 6x minus 3. We're going to subtract the second day from that. So we'll go ahead and do the rule for subtraction. We're going to have parentheses inside parentheses, so I'll go ahead and switch over to brackets right now. So a -3 is the same as plus -3. Do my rule for subtraction here. I'm going to add the opposite. There's actually that minus sign means there's a -1 as the coefficient. Again, do the rule for subtraction inside, convert these parentheses to brackets, and I go plus -1, and I'm ready to distribute. Distribute and combine like terms is how we simplify. Copy the part down that you're not using. Distribute, put a plus sign in the middle of everything. We can do that because we use the rule for subtraction. So I have negative 1 times x is negative x, or negative 1x is the same thing, right? And negative 1 times negative 1 is positive 1. So now I can combine like terms. 6x's, take away an x, leaves me with 5x's. 3 negatives, 1 positive, leaves me with 2 negatives. And we have an expression that is 5x minus 2. And that expression represents how many more customers visited the store on day 1. That's how many more. But what we need to do now is we need to evaluate the expression. This is our new skill today. We're going to evaluate the expression if x is 50. So first I did the subtraction. We learned that in our last lesson. Now I'm going to evaluate. We're learning that now, which is how to take our expression 5x plus negative 2. Evaluate means substitute the value for the variable, the number for the letter, and simplify. So I have 5 times x, or 5 times 50, plus negative 2. And this remaining number, after we evaluate this, will represent how many more customers were on the first day. So 5 times 50 is like 25 with the 0, right? 250. And a negative 2 means we have a difference of 248. So there's 248 more people on the first day. Now, like we did in our last problem, let's go ahead and check to see if this works. So if my value of x is 50, we're going to go ahead and take our two expressions for day 1. So day 1 is 6 times x. Remember, x is 50, so I got 6 times 50 minus 3. So day 1 is 300 minus 3. And 300 minus 3 is 297. Okay to use a calculator or go off to the side, that's fine too. Day 2 is x minus 1, or 50. Remember, x is 50. 50 minus 1, which is 49. So on day 1, if we had 297 people, and the next day we had 49, is that a difference of 248? So I can subtract these two. I get 248, which means it checks out. Our answer is good. Now, just a reminder, for this problem, we're not finding x. They're giving us x. We're answering this question, how many more, after we evaluate. So I want you guys to see if you can pause the video and come up with one right answer for this problem. Pause the video now and try it. So for this problem, there's more than one right answer. So they say write two linear expressions. And by linear, they mean this. It's an algebraic expression where there's an x, some kind of x, like this is a linear expression, this is a linear expression, right? Even this is a linear expression, okay? But by linear, they mean there's x, there's no x squareds, there's no x cubes, there's no x to the negative first power, no weird x's. That's what they mean by linear, okay? So for now, just kind of think of it as just another algebraic expression like we were talking about earlier. So you're going to have two things, two algebraic expressions that are subtracted, because they use the word difference, to equal, because is means equals, 5x minus 4. So what we do then is just take a look at the x's first. So here's one example of a correct answer. I know that 10 take away 5 is 5, right? So if I had 10 x's, and over here I took away, in parentheses, I took away a 5x, the difference would be 5x. How about a negative 4? What if I had a positive 1? If I had a positive 1, what would I have to take away from a positive 1 to get a negative 4? And the answer is you'd have to take away 5, right? Because that would give us a negative 4. So I'd have to take away, in parentheses, a positive 5. This should give me 5x minus 4. Now, like we did with our other problems, let's check. So I don't need to do rule for subtraction here. No need to change my parentheses to brackets. I need to do rule for subtraction here. Add the opposite. Minus sign means the same as distributing in a negative 1. No need to do rule for subtraction here because it's an addition problem already. So we're going to write down the part that we're not using. Put a plus sign in the middle of everything. distribute our -1, distribute our -1 here, and all this should equal 5x minus 4 if we didn't mess up. If we messed up, we'll go back and fix it. Combine my like terms, and I see that I have an expression that is equivalent or the same as to 5x minus 4, so we did it right. So there's one right answer. There's an infinite number of correct answers. This is just one way to do it. You wouldn't get this on a test. Just wanted you to try that. You guys go ahead and pause the video and try this problem because you will see this on your quiz. Let's try this problem. So we have a variable on top of a fraction or as a numerator. And we have to find the missing value for the variable to make this true. Or in other words, we work farthest away from the variable first. 12 take away 7 is a difference of 5. And the inverse operation is divide, is to multiply. So I multiply by the number on the bottom. That's how I isolate the variable when it's on top of a fraction to get our answer. I want you guys to pause the video and try the next problem. So we're solving this two-step equation. We have, whenever we're dealing with fractions, we just make everything a fraction, don't we? So we're going to make this into a fraction. We're going to go and convert this, start at the bottom, first multiply, then add. So I'm going to get 22/15. Over here, 6/5 is already a fraction, and we'll do rule for subtraction, add the opposite. Remember, we always put the negative up top just so we know what to do with it. So minus 4/3 is like plus -4/3 with the negative on top, same thing. Work farthest away from the variable first. I'm going to subtract this fraction from both sides. That's gone. We're left with -4/3 r on the right side. Over here, we need common denominator. The first time I multiply these numbers to other numbers, first time they're the same would be 15, but 22/15 already has 15 as denominator. No need to change it, but -6/5 doesn't. So I'll multiply it by 3/3. If I do it to the top and the bottom, it stays the same. It's the same fraction, just looks different. Just no longer simplified. Now, these guys are on the same team, so I add them when they're on the same team. I get, what's that, -40, -40/15. And at this point, it's always a good idea to simplify your fractions when you can. You don't have to. You can simplify it later. But it's not too hard to simplify, right? 40 is like 8/2 times 5. That's one way to get 40, right? Or 40 is like 4. That's 2 times 10, which is 2/5. No matter how you do it, you're going to get 3 2s and a 5. On the bottom, 15, you can just 3 times 5. That's the only way to get it. Cross out your 1s. So we have -8/3. It didn't take too long to simplify that. Again, you can do it now or later. Okay, so that was an R. My R is starting to look like an N. Let me be careful there. All right, so let's go ahead and get rid of that fraction. We've done this many weeks in a row, right? We got a fraction in front. We flip it upside down, multiply both sides. We use the multiplicative inverse. Notice that I'm putting parentheses around that negative number. Otherwise, it would mean subtraction, wouldn't it? That will make those become a 1. That's a definition of a reciprocal multiplicative inverse. Negative times negative is positive. Cross out our 1s. Factor trees, cross out your 1s. And you get an answer of 2. I want you guys to pause the video and simplify this expression. So, no need to do rule for subtraction for this first part because there is no subtraction problem. There's a negative coefficient, but no subtraction in the middle of two different terms. But there's subtraction right there. -9 means I'm going to do the rule for subtraction, add the opposite. Now I can distribute. -8 times 1 is -8. -8 times 9n is -72. Don't forget the n. And we always copy down the stuff that we're not using, right? Don't leave anything behind. So now at this point, we're going to combine like terms. The n's don't have any like terms, but the two negatives do. Add those up to get your answer. You guys pause the video and answer this question. So there's a couple ways to do this, but everything we've been doing with our proportional relationships, we've been doing with proportions, so I'll keep doing that. So I know that one package is $3. We always like to keep money on top, right? $3 per package per one package, right? So that's 3 over 1. That should be proportional equal to $15 over how many packages? Because we want to know how many you can buy, right? So then we cross multiply and divide, and we get our answer of 5. Pause the video, answer this question. Anytime we have percent, we can use percent proportion. We have is over of equals percent over 100. So 2 minutes is, so 2 goes on top. Doesn't go on top because it's smaller, goes on top because it's is. 2 is what percent of 13, so 13 goes on the bottom. We're going to find percent, so I don't know that number this time. Whatever's missing, that's where you put the x. We solve all proportions all year long by cross multiplying. And 13 times x, I hope you remember, is just 13x, right? Multiply a number to a letter, just put the number in front of the letter. Okay, we divide by the coefficient, the number in front of the letter, not the 200. And this is where we get to break out our calculator. Hallelujah, right? No more that long division. We're going 200 divided by 13. And since we use percent proportion, no need to convert this by moving the decimal. Looks like we got about 15.4. And let's see what our answer is. Hopefully we didn't mess up. Yep, 15.4%. Pause the video and you guys go ahead and find the area of this circle. So the area of the circle is always pi r squared. And so we need to get radius. We can use 3.14 for pi, or your pi button if you would like. So we'll go ahead and take our number 9.6, all the way through. Remember what that's called? And I hope you just said diameter right now. So divide it by 2 to get our radius because it gave us diameter. So we got 4.8. So I'll go 4.8 times 4.8. We want to do our exponents first. That equals 23 and 400ths. Now we can multiply that by pi. And just remember, if you are close, you are correct. So if we're a little bit off, maybe a couple units or a couple hundredths of a unit off, then you're right. Okay, now if you're 10, 100, or 1,000 off, you obviously did it wrong. And let's try to find volume for our last problem. Pause the video now. So this is a triangular prism, meaning that the two bases, the two parallel congruent sides, are triangles. So in order to find the volume of any prism, we find the area of the base times the height. So the only tricky part about this is they give us a 3 here, they give us a 4 here, and they give us a 5. We're only going to use 2 of those to get the area of the triangle. So you have to know which 2 to use. And base and height are always perpendicular. So you must use the ones that make the rectangle. I'll say it again. You have to use the numbers that make the rectangle. We won't be using 5 for anything for this problem. So I go 3 times 6, because that's base and height of the triangle, not of the whole prism. So area of a triangle is base times height divided by 2. I got 3 times 4 is 12 divided by 2 is 6. So the area of the base is 6 multiplied by the height. 6 times 6 is 36. Do not forget to use meters cubed or units cubed since it is volume. All right, so it looks like that's it for today. Let's see if I can get this up here. Here it is over here. All right, we'll see you guys soon.